Good morning, ladies and gentlemen. I'm glad that you still have the ability to hear my voice on this Thursday, even though I am not in front of the classroom right now. Good news for you is that you still get a corny joke for today. So if you notice the picture, that these two angles, they're a 90-degree angle. So I'm telling you, thanks for the compliment, and there is your humor for today. The good news is that after this lesson, your learning target for the day is that you will be able to write and solve ratios and proportions. So if you do, notice the very first thing that you have on your note sheet is a ratio. It is a comparison of two quantities using division. There are three different ways that you can write a ratio. One of them is actually as a division, A divided by B. Another way is A to B. Okay, where A comes first and B is the second part of it, which we'll talk about in our next example. And last but not least, this is the way that you may most often know a ratio as written. I will accept any of those three as acceptable answers. If you look at the first example, it says 30 girls tried out for 15 spots on the basketball team. What is the ratio of spots to the number of girls competing? The key is that the spots comes first. So if we are setting up a fraction, we need to make sure that the spots is in the numerator and the number of our girls is in the denominator. So that means that we have a 15 over 30 as we pick out our information from the actual question, and we reduce that down so we have 1 to 2. If you would write it the other way, okay, you would use the 1 to 2, okay? Either one of those options are more than okay. And if you'll notice on your note sheet, we also have what's called an extended ratio. An extended ratio is a ratio used to compare three or more quantities. So the second example talks about the ratio of the measures of angles in triangle ABC is 6 to 8 to 10. It says find the measures of the angles. Well, the first important thing is we have a triangle. We know that the measures of the angles in a triangle equal 180 degrees. So we have three angles in a triangle. That's where we get the 6, the 8, and the 10 from. So when we actually do set up our equation now, we have our 6x plus our 8x plus our 10x is actually equal to our full sum of our interior angles, our 180 degrees. Well, we combine our like terms, we end up with a 24x that is equal to our 180, or we end up with our x that is actually equal to a 7.5. Okay. Good news is now it says find the measures of the angles. We need to plug this 7.5 back in place of the 6x, of the 8x, and of the 10x. So the measure of one of our angles would end up being 75 degrees. The measure of our second angle would be 60 degrees. The measure of our third angle would be equal to 45 degrees. And now we found out what the three angles were given this extended ratio. On to the second part. Now we are talking about a proportion. A proportion is an equation stating that two ratios are equal. So the only difference now is that we have two ratios put together. A over B is one of the ratios. Then we have our is equal to C over D. And so once we have this, the key is that there are certain names for each one of these numerators and denominators. For our for our ratio on the left-hand side, we know that the extreme is the top, and then you will think this word looks very similar or very familiar, and it's a mean. So we have an extreme over a mean. Well, on the right-hand side of our proportion, we have the complete opposite because these are supposed to be equal. So we have our mean that lays in our top, and we have our extreme that gets switched at the bottom. So what we're going to do now is we are going to try to solve proportions. The way that you solve a proportion is by your cross product property. And it says the word product right in the definition. That means we are going to be doing some type of multiplication. We're going to multiply the two extremes together So if you notice, we have our A times our D, those are our two extremes. Then we are going to multiply our means together, our B times our C. So let's actually do that, and we'll start with the second example first. So we are going to multiply our extremes, our 5 times our 21. So we multiply 5 times 21. That's going to equal our 7 times our x. So it's just equal to a 7x. Well, when we multiply the 5 and the 21 together, we actually get a 105. That is equal to our 7x, and now we're trying to solve for x. So we divide by 7, so we get our x. That is equal to 15. You notice example A, it looks a little more confusing. We multiply our extremes together again. We have our 5 multiplied then by our x plus 3. There's going to be a little distribution that we're going to have to do with this. Well, if you notice the second side then, we have our 2, our means, need to be multiplied 2 times our 4x. Well, as you're looking here, we distribute on the left-hand side. So we get our 5x plus our 15. That is equal to our 2 times our 4x, or our 8x. Now we combine like terms. So we subtract the 5x from both sides of our equation, end up with a 15 that is equal to a 3x. And last but not least, we divide by our 3. So we end up with our x that's equal to 5. Every single proportion that we try to solve is going to be solved based on our cross product property. Now, last but most certainly not least, we have different proportions depending on how we label the means and extremes that can be equal to one another. When they are equal to one another, they are called equivalent proportions. The following proportions are all equal. So we start with the most basic. Our A over B is equal to our C over our D. Okay. Let's give an actual example right away too. We'll put down the numbers 2 over 3. So the fraction 2 over 3 is equal to 6 over 9. Hopefully you can see right away that both of these, 2 over 3 and 2/3 is equal to 6/9. They're just simplified, broken down a little bit. Well, what we're going to do now is we are going to switch the means and extremes, top to bottom. So what that means is now, if we switch the left side of our proportion, so now we have our B over our A is equal to our D over our C. Is this still equal? Let's find out. We switch a 3 over a 2. Is that equal to a 9 over a 6? Yeah, you bet it is. Okay, they're both still going to be equal to 1.5 if you would simplify them down. Well, the third way that we could do this is we could put the numerators together now and make one side of our proportion. So we have our A over C that is equal to our B over D. And if we actually put this in a number form now, we end up with a 2 over a 6 that is equal to our 3 over a 9. All different ways that we can write a proportion that still makes them exactly the same as one another. Then last but not least, we can flip our C that we just did as well. So we now have C over A is equal to our D over a B. And if we write this out in numbers again, we flip 6 over 2 is equal to our 9 over our 3. You'll notice that that is all equal as well. Okay, so hopefully you are now experts on proportions, ratios, and solving proportions. So your homework for Friday, which we will answer questions at the beginning of class on Friday, is your homework sheet 7.1. Complete the first side of that for Friday. Have a good rest of your day.